Welcome to G Fun Facts Online. What if I told you that the story of humanity isn't just buried under layers of Earth, but is also written in the light of distant stars, etched onto the surface of the Moon, and maybe, just maybe, hidden in signals from civilizations long gone? Today, we're diving into a fascinating scientific frontier that looks both to our most ancient past and our most ambitious future. This is the world of astro-archaeology, a field that connects the dots between the stone circles of our ancestors and the silent satellites adrift in the cosmic ocean. It's a discipline with three incredible branches. First, there's archaeoastronomy, which uncovers how ancient cultures read the sky. Then there's space archaeology, which preserves our own first steps into the cosmos. And finally, the most mind-bending of all, xenoarchaeology, the speculative search for the artifacts of alien life. Together, they tell the story of our species' long and intimate relationship with the final frontier. So let's begin our journey. Our first stop takes us back in time, to an era long before telescopes and spacecraft, when our ancestors were brilliant observers of the heavens. This is the domain of archaeoastronomy, the science of deciphering the celestial blueprints of the past. For thousands of years, people tracked the movements of the sun, moon, and stars, and they didn't just watch. They embedded this cosmic knowledge into their most sacred structures, their rituals, and their entire worldview. This field really took off in the 1960s, thanks to researchers like Gerald Hawkins, who famously proposed that Stonehenge was a complex astronomical observatory. Archaeoastronomers today use a couple of key methods. What they call green archaeoastronomy involves the hard data, the statistical analysis of how ancient buildings are aligned. They look for patterns that are too precise to be coincidental. But they complement this with brown archaeoastronomy, which dives into historical texts, cultural stories, and anthropology to understand not just what these people saw, but why it mattered to them. Let's look at some incredible examples. First, Stonehenge in England. Everyone knows its main axis is aligned with the summer solstice sunrise and the winter solstice sunset. But the story is much deeper. Researchers have found numerous lunar alignments, suggesting that its builders might have been tracking the complex 18.6-year cycle of the Moon. Some even theorize it could have been used to predict eclipses, making it a kind of Neolithic astronomical calculator, built from stone and sheer ingenuity. Now let's travel to Ireland, to a site even older than the pyramids of Giza Newgrange. This is a massive, grass-covered passage tomb, a masterpiece of Neolithic engineering. For just a few days around the winter solstice, a remarkable event occurs. The rising sun shines through a small, perfectly placed opening above the entrance, called a roof box. A beam of light then travels down a long passage and illuminates the central chamber for about 17 minutes. This stunning display is thought to symbolize rebirth, the triumph of light over darkness at the darkest time of the year, showing just how deeply celestial events were woven into the spiritual fabric of their culture. Finally, let's cross the Atlantic to Chaco Canyon in the United States. The ancestral Pueblo people who lived there left behind an astonishing record of their cosmic knowledge. On a place called Fajada Butte, they carved a spiral petroglyph. 3 large stone slabs were positioned in front of it, in such a way that on the solstices and equinoxes, daggers of pure sunlight would pierce the center or the edges of the spiral, marking the key points of the solar year. This sun dagger is just one example. The very buildings in the canyon show precise solar and lunar alignments, indicating a sophisticated society whose ceremonial and social life revolved around a deep understanding of celestial cycles. From the ancient past, we now leap forward to our own era. As humanity began its journey into space, we started leaving behind a completely new kind of archaeological record. This is the realm of space archaeology, a field dedicated to studying and preserving our unique, off-world heritage. Pioneers like Dr. Alice Gorman and Justin Walsh are leading the charge, arguing that everything from launch pads on Earth to our footprints on the Moon holds immense cultural and scientific value. They are the curators of our cosmic history. So how do you conduct an archaeological dig in space? The methods are as innovative as the subject. For sites on Earth, like old launch complexes, they use remote sensing technologies, like satellite imagery and LiDAR. But for inaccessible sites, like the International Space Station, they've had to invent new techniques. Let's look at the incredible sites they study. First, the archaeology of the Moon. The 6 Apollo landing sites are, without question, the first human archaeological sites on another world. They contain priceless artifacts, the lunar modules, rovers, scientific equipment, and even more personal items left behind by the astronauts. And of course, there are the iconic footprints, perfectly preserved in the lunar dust where there's no wind to blow them away. These sites are also accidental experiments. They give us a unique chance to see how human-made materials hold up over decades in the harsh lunar environment, blasted by radiation and extreme temperatures. This data is vital for designing future missions. Recognizing this, there's a growing movement to protect these locations. The US even passed the One Small Step to Protect Human Heritage in Space Act to ensure these sites are preserved. Now let's look at archaeology in action. Right now, in orbit, the International Space Station Archaeological Project, or ISSAP, is the first large-scale archaeological study of a human habitat in space. They are studying how humans adapt to life in microgravity. One fascinating method is the square experiment, where astronauts take photos of the same 1-meter square area over time. By tracking how items appear, move, and disappear, researchers can map how the space is actually used. They've found that the crew's use of the station often differs from the designer's original intent. For example, areas meant for maintenance get repurposed for storage, and astronauts create informal personal spaces. This is archaeology of the living, and it provides crucial insights for designing more efficient and comfortable long-duration habitats for future missions to Mars and beyond. But not all of our space heritage is so neatly contained. There's also the archaeology of space debris. The cloud of junk orbiting Earth, made of everything from defunct satellites to tiny fragments from explosions, is a serious hazard. But space archaeologists see it differently. They argue that this space junk also has cultural significance. These artifacts tell the story of the space race, the Cold War, and the evolution of satellite technology. This creates a difficult debate. How do we balance the urgent need to clean up this debris with the desire to preserve historically significant objects as part of our shared space heritage? Which brings us to our final and most speculative branch. What happens when we turn our archaeological gaze from our own history to the potential history of others? This is xenoarchaeology, the hypothetical search for and study of the material remains of extraterrestrial civilizations. While it might sound like pure science fiction, scientists are laying the conceptual groundwork for it today. The logic is simple and profound. The distances between stars are so immense that any evidence we find of an alien intelligence, whether it's a radio signal or a physical artifact, will likely come from a civilization that is long extinct. In this sense, the entire search for extraterrestrial intelligence, or SETI, can be seen as a form of archaeology, sifting through the cosmos for the ruins of other minds. The modern search is expanding beyond just listening for radio signals. Scientists are now looking for technosignatures, any observable evidence of technology. This could be anything from the chemical signature of industrial pollution in an exoplanet's atmosphere, to the glow of city lights on its night side, or even massive astroengineering projects like Dyson spheres. This is, in essence, a form of remote sensing xenoarchaeology. But what if an artifact came to us? In 2017, the scientific community was electrified by the discovery of Oumuamua, the first interstellar object ever detected passing through our solar system. Its characteristics were bizarre. It had a highly unusual, elongated shape, and it was accelerating away from the sun in a way that couldn't be easily explained by gravity alone. This led some, most notably Harvard astronomer Avi Loeb, to speculate that it could be an artificial object, an alien probe, or a light sail. While most scientists believe Oumuamua had a natural origin, its strange properties show us exactly the kind of anomaly that could trigger a full-blown xenoarchaeological investigation. Beyond waiting for things to drift by, some researchers are actively searching for artifacts closer to home. This field, known as planetary SETI, involves looking for structures or objects on the surfaces of the Moon, Mars, and other bodies in our solar system. While past claims, like the infamous face on Mars, have been debunked by higher-resolution images, the idea of searching for physical remnants of a past extraterrestrial visit continues to be a serious topic of scientific discussion. As you can see, astroarchaeology is a field that truly spans the breadth of human experience and imagination. But it's not without its challenges. Archaeoastronomers have to be careful not to impose modern ideas onto ancient cultures. Space archaeologists are fighting to protect our off-world heritage from future space tourism and missions, and the entire field must grapple with the profound ethical and societal implications of a potential discovery of extraterrestrial life, which could reshape our understanding of our place in the universe. The future of astroarchaeology is as vast as the cosmos it studies. New technologies will allow us to analyze ancient sites in stunning detail. Upcoming missions to the Moon and Mars will create new archaeological sites for future generations to study. And the search for techno-signatures is set to explode with the next generation of powerful telescopes. From the sun-bleached stones of ancient temples to the silent, frozen footprints on the Moon, astroarchaeology reveals the deep and unbreakable bond between humanity and the cosmos. It reminds us that our history isn't just written in the dust of the Earth, but also in the light of the stars, and the vast silent artifacts we've left in the space between them. Thanks for tuning in to G Fun Facts Online.